Hello everyone. Let me introduce myself, Revati, Assistant Professor, Department of Artificial Intelligence and Data Science, Ramco Institute of Technology, Rajapalayam. Now we are going to discuss about the familiar concept of merge sort. First, we discussed about what is meant by sorting. A sorting algorithm is used to rearrange a given array or list of elements according to a comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure. The basic principle of sorting is involved. Sorting is the process in which items are arranged systematically. The arranged of elements in a specific order based on the certain criteria. Sorting algorithms are used to reduce the complexity and optimize the use of other algorithms. There are different types of sorting are bubble sort, quick sort, selection sort, merge sort, insertion sort, heap sort, and etc. From this, we will discuss the merge sort algorithm. Merge sort is defined as a sorting algorithm that works by dividing an array into a smaller subarrays, sorting each subarray and then merging the sorted subarrays back together to form the final sorted array. It is one of the most popular and efficient sorting algorithm. It divides the given list into two equal halves, calls itself for the two halves, and then merges the two sorted halves. We have to define the merge function to perform the merging. Then, in this slide, we will discuss what is the meaning of divide and conquer. Divide and conquer is a problem solving strategy that involves breaking down a complex problem into a smaller, more manageable parts, solving each part individually, and then combining the solutions to solve the original problem. It is a widely used algorithmic technique in computer science and mathematics. This technique can be divided into the following three parts. First one is divide. This term involves dividing the problem into smaller subproblems. The second one is conquer. Conquer is to solve subproblems by calling recursively until solved. Then combine. Combine is the subproblems to get the final solution of the whole problem. Divide and conquer algorithms work faster because they end up doing less work. This is the working flow of divide and conquer method. In this diagram, first we take a problem as n size, and the problem will be divided into two halves, that is n by 2. That part will be called as subproblem. Again, the subproblem can be divided into two halves, that is n by 4. This process is continue until all the elements in the problem up to the end of the array. Each subproblems can be solved based on the n by 2 size. Finally, we combine the subproblem solution to the final one. Now, let us see the algorithm for merge sort. In step 1, we have to find the middle index of the array. Formula for this middle equal to 1 plus last minus first divided by 2. In step 2, we have to divide the array from the middle. And then the step 3, we can call the merge sort for the first half of the array. This is the syntax of the first half of the array merge sort. Merge sort of array comma first comma middle element. And then step 4, again we have to call the merge sort for the second half of the array. Then the same merge sort syntax array comma middle plus 1 comma last element. And then the final step, merge the two sorted halves into the single sorted array. So this is the working principle of, and this is one of the example of the merge sort. Consider an array having the following elements 1, 6, 3, 2, 7, 5, 8, 4. We have to need to sort this array using the merge sort. In this slide, there is a total of 8 elements in the array. Thus, middle element is 4. So, we will first divide this array into two arrays of size 4 as shown in the figure. Next, we recursively divide these arrays into further halves. The half of 4 is 2. So now we have 4 arrays of size 2 each. The next one is, we will keep on dividing into further halves until we have reached an array length of size 1 as shown in the figure. After this, we have the combining step. We will compare each element with its consecutive elements and arrange them in a sorted manner. In the next iteration, we will compare the two arrays and sort them as shown in the figure. Finally, we will compare the elements of the two arrays, each of size 4, and we will get our resultant sorted array as shown. So, this is our final sorted array of the merge sort. Thank you.